All right, so I'm going to work through this worksheet. So I'm going to start at the beginning. So if you need a specific problem, feel free to fast forward the video so that you can get to the question that you want and or need. Okay, so let's see. First thing, I always like to and suggest that you sketch a drawing to represent the situation, because I think a lot of times it's easier to see what you're looking for if you have a visual to look at. So, model rocket is launched from the roof of a building. Its flight path is modeled by that equation. H is the height of the rocket, and T is the time in seconds. So what's happening here is we have a building. So I'm just going to say that's my building right there. Let's see if this focuses a little bit better there. There we go. All right. And then the rocket is being launched from the top of the building, and then it's going to come down and hit the ground. So what this is showing me is I'm thinking this is the x-axis, because this would be the ground. And this would serve as the y-axis, because this parabola is not starting from the ground. The rocket is being launched from the top of a building. Now, if we use the information that we know, this would be the y-intercept. And we can find the y-intercept because the y-intercept is when time is 0. So if I put 0 in place of the time, I know that this right here, oops, I think I'll go this way, is 10 yards off the ground. So the building is 10 yards, the roof where the rocket is being launched, that's 10 yards, kind of head start from the ground. All right, so first up, how long is the rocket in the air? Well, if I wanted to know how long the rocket was in the air, I need to find the x-intercepts. So specifically, I want this point right over here, because this is going to tell me how long the rocket is in the air. So I am going to find the x-intercept. All right. In order to find the x-intercept, I need to complete the square. I could solve by factoring. I could solve by quadratic formula. Looking at this equation, I'm not able to factor it, and I know that by kind of looking ahead. If I take out a GCF, I'm going to be left with a -2 here and a 6 here, and there's no way to multiply to get 2, but add up to 6. So I know factoring is not an option. Not crazy about quadratic formula with these numbers, so I am going to go with completing the square. All right, so first thing that I need to do is move the 10 to the other side. So I'm going to put my scratch work out here. So I have -5t squared plus 30t equals -10. On the left side, I am going to take out -5 because we don't, or when we complete the square, we can't do our shortcut with a leading coefficient. So that's going to leave us with t squared minus 6t plus blank equals -10 plus blank. All right, magic number here should be 9, which means over here it's -45. So now on the left side, I have -5. This is going to factor to be t minus 3 squared. This one over here is going to be -55. All right, now, if I wanted vertex form, I can stop right there and then bring the 55 over to the left. But we are solving, so we're going to keep going. So divide both sides by -5. So t minus 3 squared is 11. Take the square root of both sides. So that's going to be plus or minus the square root of 11. So t is going to be 3 plus or minus the square root of 11. Now, I know looking at my picture here that I do have two x-intercepts. One of them is going to be in the negative, and that's not going to make sense in this problem. So what I'm looking for is the positive x-intercept, the one that's on the right, and I would get that by doing 3 plus the square root of 11. So next thing I'm going to do is think about how I would estimate the square root of 11. And I'm going to estimate that to be about 3.3, which tells me that the rocket is going to hit the ground about 6.3 seconds. So I'm going to go over here, and how long is the rocket in the air? It is approximately 6.3 seconds. So again, we didn't use the 3 minus the square root of 11 because that would have been the negative x-intercept, which would not have applied in this problem. All right, next part. What is the rocket's maximum height? Well, anytime I hear the word maximum or minimum, I need to think of vertex. So specifically for the height, I need the y of the vertex. So I am looking for the y of the vertex for this problem. All right, so I'm looking for this point right here. Well, we were already starting to do vertex form. So probably the easiest thing to do, easier than doing negative b over 2a and filling it in, which is what I would do in standard form, I was starting to get vertex form right here. So if I take this down here, I can say that y is negative 5 and then t minus 3 squared plus 55. So that gives me vertex form. So now looking at vertex form, I know that the maximum height is going to be 55 yards. So the maximum height is 55 yards. All right, moving on. Next problem. All right, number 2. Sorry, they're testing the intercom. Juan jumped off a cliff into the ocean while vacationing with his family. His height is modeled by this equation. So this equation right here is going to give us the path of his jump. T is in seconds and the height is in feet. All right, so he is jumping off of a cliff into the ocean. So I'm going to say, here's my cliff, and Juan is up here. He is going to jump off and then land and hit the water. So this is similar to our first problem where I'm going to look at this as the x-axis and this as the y-axis. All right, so if this is the y-axis, I know that the time would be 0. So if I go back in here and fill in the time, I can see that this is the starting height. So when we're in standard form, this is giving you your starting height right here. So the cliff is 480 feet in the air. So the height of this cliff is 480 feet. All right, so here we go. So how long after jumping did Juan reach his highest point? Highest point. Anytime I hear highest point or lowest point, I need the vertex. And since this is the time, I need the x of the vertex on this part right here. All right, so here we go. So if I need the x of the vertex, I have standard form, so I'm going to do negative b over 2a. So negative b over 2a. So negative b would be negative 16. 2a is negative 32, which gives me 1/2. So Juan is going to reach the vertex of his jump after half of a second. So how long after jumping? 1/2 of a second. All right, next up. How high did Juan jump? So again, anytime I hear highest or lowest, I know I need the vertex. And the height of the vertex is going to be the y. So now I need the y of the vertex. All right, no big deal. So what that means is that I need to fill in 1/2 into the equation. So his height is going to be, so we have negative 16 times 1/4. So that would be negative 4. and then plus 16 times 1/2, which would be plus 8, and then plus 480. So if we work that out, we get 484 feet. So I know that the vertex, the highest point, was 484 feet. Now, the question asked, how high did Juan jump? Well, he didn't jump 484 feet. He only actually jumped 4 feet. So be careful, make sure you're answering the questions that you're being asked. So Juan jumped 4 feet because he started at 480 feet. All right, next one. After how many seconds did Juan hit the water? All right, so for this one, I'm looking for the x-intercepts because the water is like the ground. So I want to know, when does Juan land right here? Okay, when does he hit the water? So I'm trying to figure out how much time it is right here. So in order to do that, I need the x-intercepts. So now we're kind of taking it that this is at 0 right here, but once we get the two x-intercepts, if one of them isn't 0, then we just need to subtract them to find the difference. All right, looking at this problem, I'm going to go for factoring. So anytime we are looking for the x-intercepts, we can do that by factoring, completing the square, or quadratic formula. I'm going to try factoring because I know that I can pull out a negative 16 from all three of the coefficients in that trinomial right there. All right, now that I have that, I'm going to factor this trinomial, and I can use negative 6 and positive 5. So now I know this answer is 6, and that answer is negative 5. Well, I know this one doesn't make sense because that's the one that would be in the negatives. So it looks as if this is 6 seconds right there. So Juan will hit the water in 6 seconds. All right, awesome. Let's keep going. All right, a scuba diver is going underwater to retrieve the camera that he dropped. We have his equation, which is given to us in vertex form right here. And the dive, and I did not put units in here, so we'll just call it feet. And then the time is in seconds. All right, so we have a diver this time. So I'm going to think of the surface of the water as my x-axis. So here is our scuba diver, and his camera is somewhere down here. So what's happening is he's diving down to get his camera and then coming back up to the surface. So that's the parabola that I'm looking at. All right, first up, how long is a scuba diver underwater? So how long he's underwater. So what I want to know is if he goes down underwater right here, he's going to come back up right here. So I'm looking for the x-intercepts. All right, so go over here. I want the x-intercepts. All right, now we can do x-intercepts by completing the square. We can use quadratic formula, or we can solve by factoring. My thought on this one is that I have vertex form, and the way we get vertex form is by completing the square up to a certain point. So what I'm going to do is I'm going to change this back into completing the square and then keep going. So if I was doing completing the square, I would have 1/2 and then t minus 6 squared equals 18. Because if you remember, when we were doing completing the square, we got to vertex form by bringing this back. So if I put the 18 back over, I can go back to completing the square to finish the problem. All right, so here we go. I need to get rid of the 1/2, which I would do by multiplying both sides by 2. So that would give t minus 6 squared equals 36. Take the square root of both sides. So t minus 6 is plus or minus 6. All right, I'm going to move up here. So that means that t is 6 plus or minus 6. So that means that I get 0 for one of them and 12 for the other. Well, obviously, this is 0 seconds right here, and this is 12 seconds. So I can tell that the scuba diver was underwater for 12 seconds. So if you're noticing, hopefully all we keep doing is either finding the vertex or finding the x-intercepts. That's it. That's all we keep doing over and over, just different numbers. Okay, next up, what was the depth of his dive? Well, anytime I hear something about highest or lowest, I know that I need the vertex. So I need the vertex, and specifically, since I'm looking how deep he dove into the water, I am looking for the y of the vertex. All right, well, it just so happens we were given in vertex form. So if I look up here, I can tell the y of my vertex is negative 18. So if this point right here is negative 18, it's kind of redundant to use the negative. So the depth of his dive, he dove 18 feet. So we don't need the negative because when we say that he's diving or the depth, that's implying a negative value. All right, keep going, on to the back. All right, so a diver is standing on a platform that's 24 feet above the pool. He jumps from the platform with initial velocity of 8 feet per second. Here's the basic formula, okay? H is the height, T is the time, V is the velocity, and S is the starting height. All right, wow. So when I look at my equation, I wasn't actually given the equation. First question is, what is the equation? Well, I mean, my gosh, right? So V is velocity, which I was given right here. And then the S is the starting height, which I was given right there. So the equation for the diver's jump is that his height in seconds is negative 16t squared plus the velocity plus the starting height. So there you go. There's the equation. And we mentioned on the other side that we know the starting height is the 24. When we have standard form, this is always our starting height because time is 0. So if time is 0, those two things are gone, I can tell the starting height is going to be at 24 feet. All right, how long will it take for the diver to hit the ground? All right, well, let's go to our picture here. So we have a diver on a platform. So he's standing up here. All right, and then down below him is the pool. And we know that this platform is 24 feet above the pool. All right, so we'll say this is like the side of the pool here. All right, so he is diving. So what that means is that he's going to probably have a little bit of a jump and then go down. So very similar parabola to the ones that we had on the previous page. All right, how long will it take him to hit the water? So what I want to know is when is he going to get to ground zero, which is this right here. So I'm looking for the x-intercept. So we need to find the x-intercept. Now, we could again assume that this is the x-axis and this is the y-axis right there. But either way, we're still having to solve to get the x-intercepts. Okay, so how long will it take for him to hit the water? So here's my, right here is my equation. To find the x-intercepts, I could do quadratic formula, which I don't really want to do on those numbers. completing the square, which I'm not entirely crazy about since I have a leading coefficient. So the other option is factoring, and I do see a common factor in here. So I'm going to try factoring. If factoring doesn't work, then I know I'll have to complete the square or use quadratic formula. All right, so out of this right here, I'm going to take out a GCF of -8. So that is going to leave 2t squared minus t minus 3. All right, so now what I want to do is try and factor this. Well, in order to factor this, this is a trinomial with a leading coefficient. So whatever you do to do that, some of you might use the big X, but we're looking for numbers that multiply to be -6, that add up to -1. And if I think about that, I know a -3 with a +2 would multiply to be -6, but add up to -1. But we do have a leading coefficient out there. So when I rewrite this in factored form, this is going to be 2t minus 3. And this one is going to be t plus 1. All right, so the answer for this one would be 3/2. The answer for this one is -1. Well, I'm looking for the positive x-intercept, so I know that one's not what I want. So 3/2 is this spot right here, which I know that 3/2 is the same as 1.5. So he's going to hit the water in 1.5 seconds. All right. Not bad. All right, next up, path of a golf ball hit into the air follows this equation. H is the height in feet, and T is the time after being hit off the tee in seconds. All right, so here's my situation. So I am golfing. So here's my little golf club here. All right, and I am going to hit the ball, and it's going to go up and then land. So this is going to serve as my ground right here, which would be our x-axis. And then we are starting from the ground, which is why, remember, when we're in standard form, this tells us our starting height. Well, our starting height is 0 because the ball's on the ground. All right, here we go. So how long is the golf ball in the air? So what I want to know is, when does the golf ball land? So the golf ball is going to land right over here, which means I need to find my x-intercepts. All right, how do you find your x-intercepts? Well, we could use quadratic formula, we could use completing the square, or we could try and factor. And I'm going to try and factor because I know that 16 and 64 have a common factor here. So I'm going to take out a -16t, which is going to leave me t minus 4, if I did that right. So this x-intercept is 0. This x-intercept is 4. So I know that I hit the golf ball at 0 seconds, and it hit the ground 4 seconds later. So the golf ball was in the air for 4 seconds. All right. What is the maximum height of the golf ball? Anytime I see minimum or maximum, I know that I am looking for the vertex. And specifically for this problem, since I want the height, I am looking for the y of the vertex. All right, so let's see. We could do this 2 different ways, honestly. So one thing is I could do -b over 2a. That gives me that, and I can fill it in, which is probably the easiest and best way. I also know that since it started and stopped at the x-intercepts, I know that my vertex is going to be right here at 2 something. So I'm going to look at my x-intercepts and average Because remember, even though I got standard form here, I know that my vertex is occurring at 2 something because I'm going to average my x-intercepts together. All right? If I did negative b over 2a, I would still get 2. All right, now to figure out the height, I need to fill in 2 into the equation. So my height is going to be negative 16 times 4 plus 64 times 2. All right, so this is negative 64. This is positive 128. So I'm getting 64 feet. So the maximum height of the golf ball was 64 feet. All right, here we go, next step. We're getting there. All right, fireworks. So we're shooting fireworks off at a slight angle from a height that's 4 feet off the ground. So we're not shooting them from the ground. Maybe they're sitting on a table. 4 feet off the ground. Path of the fireworks is given right here. H is the height in feet and T is the time in seconds. And this confirms that my starting height is 4 feet off the ground because my starting height would be when time is 0, and time is 0, my height is 4. All right, so let's see. I don't really know what fireworks look like, but I'm just going to make a table here that I know is 4 feet off the ground. Whoops. And then I know that the fireworks are going to go woo, and then the debris is going to come back and hit the ground. Now, it's going to go up here, and it's going to go pow, 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 whatever. Let's add another pretty color up there. All right, so the fireworks are going to go up. They're going to make their pretty and very loud sound, and then the debris is going to come back and hit the ground. All right, so this is the ground, which is my x-axis, and then I know time is 0 right here. All right, so what's up? First thing, maximum height of the firework. Anytime I hear about maximum or minimum height, I know I need the vertex. And in order to get the height, I need the y. So I am looking for the y of the vertex. All right, so I was given standard form here. So I'm going to do negative b over 2a, get the x, and then I'm going to have to fill it back in. Okay, so first off is the x. So negative b over 2a, and that's going to give me 5. So I know that this happened after 5 seconds. All right, so now I want the height of the fireworks, so I'm going to fill 5 in. So I have negative 16 times 25, and then 160 times 5 plus 4. So this would be negative 400. This is 800, and then plus 4. So it looks like the maximum height was 404 feet. All right, so this happened right here. It was after 5 seconds, and the fireworks were at 404 feet. So that is the maximum height of the fireworks. So we don't need to worry about the fact that it was 4 feet off the ground. So it still went up to 404 feet in the air. All right, when will the debris from the fireworks hit the ground? Well, here you go. We were just saying this. So here's where the debris hits the ground. Anytime I mention hitting the ground, that means I need to find my x-intercept. So we need to find the x-intercept over here. All right, so I think I'm going to go with, all right, let me think about this a little bit. Okay, I'm not thinking that factoring is going to work because if I took out a GCF, I have a 1 right here. I'm not going to get something bigger there with the 1. So I really don't want to do quadratic formula with these numbers, so I'm going to go with completing the square. All right, so first thing I'm going to do is move the 4 to the other side. So negative 16t squared plus 160t equals negative 4. I'm going to take out my leading coefficient here. So that's going to give me t squared minus 10 plus blank equals negative 4 plus blank. All right, my magic number should be 25, which if I multiplied 25 and negative 16, that would be negative 400. All right, so now I can factor this to be t minus 5 squared equals negative 404. All right, now I'm going to divide both sides by negative 16. So I need more space here. All right, so now I have t minus 5 squared. All right, now I know I have a positive, and I know I can reduce both of these by 4. So I'm going to say 101 over 4. Okay. Now I need to take square root of both sides. So that's going to give me t minus 5 equals plus or minus square root of 101 over 2. All right. So keep going here. So now I have that t is 5 plus or minus square root of 101 over 2. All right, now I'm going to do some estimating here, okay? The square root of 101 couldn't be any closer to 10, right? But we'll just say it's a little more than 10, okay? So if this is a little more than 10 divided by 2, then this is going to be a little more than 5. All right, so now I have 5 plus 5.1 and 5 minus 5.1. I don't want the negative one, I want the positive one. So I'm going to say that my x-intercept is approximately 10.1 seconds. So it's going to take approximately 10 seconds for the debris to return back to the ground. So again, what I did right here is I estimated the square root of 101 to be approximately 10. It's a little more than 10. So a little more than 10 divided by 2 is going to be a little more than 5. So now I have 5 plus, and I'm just going to say 5.1 since it's a little more than 5. All right, last one. Here we go. Okay, you and a friend are hiking in the mountains. You want to climb to a ledge that's 20 feet above you. The height of the grappling hook you throw is given by this equation right here. So how high above is the grappling hook? And then can you throw it high enough to reach the ledge? All right, so here's our situation here. So you and your friend are hiking. So you're down here, okay? There's a ledge up here, all right? So what's happening is you are throwing up a hook that's connected with a rope, by the way. So you're throwing it up, and it's going to come back down. Now, the thing here is you're trying to figure out, excuse me, if you can reach that ledge. Okay, so first up, sorry, how high is the hook? Again, anytime I hear the question, excuse me, about the highest point, I know I'm looking for the vertex. So for this, if I want to know how high is the grappling hook, then I am looking for the y of the vertex. All right, so let's see. We were given standard form, so I think I'm just going to do negative b over 2a and then fill it in. All right, so if I do, excuse me, negative b over 2a, I get 1. which is awesome because that's easy to fill in. So now the height of the grappling hook is going to be negative 16 minus 32 plus 5. Oh my gosh, hold on. Negative b, I forgot. That should be a positive one. Ah! So this is a negative one. The tickle in my throat is throwing me off here. All right, so negative b should be 32 over 2a. That gives me negative 1. So I fill in negative 1, and that's going to affect that answer right there. So just a redo there. Sorry about that. All right, so let's see. That would be 16 plus 5, so 21 feet. So I know if I put a vertex to this, it would be negative 1, 21. All right. So that is where the hook, so I threw the hook up in the air. So the hook could reach 21 feet. So can I throw it high enough to reach the ledge? Well, if the ledge is 20 feet above me and I was able to throw that hook 21 feet into the air, then yes, I can throw the hook 21 feet. So yes, I can throw the hook high enough to reach the ledge. So I guess the answer to that one is yes. Yes, I can. All right, so in summary, I just want to point out that on every single one of these problems, we were either finding the vertex or the x-intercepts. The vertex or the x-intercepts. Same thing on the front. We were always doing the vertex or the x-intercepts. So keep in mind that if you are looking for the highest or the lowest, you need the vertex, and you know how to find the vertex. You could do negative b over 2a. If it's in standard form, if it's in vertex form, it's given to you. If you know the two x-intercepts, then you can average them. And then to get the y value, we just fill those back in. If you're having to find how long it took for something to happen, or maybe if you kicked a ball and you wanted to know, let's just say on this golfing one, if you hit the golf ball in the air and you wanted to know the distance, it's still the x-intercepts. In order to find the x-intercepts, you can do completing the square to solve, you could solve by factoring, or you could solve using quadratic formula. Now, a lot of times quadratic formula is not ideal because of these crazy large numbers that you're getting in these problems, but it still is an option. But again, we are finding the x-intercepts or the vertex on every single one of these questions. So, have confidence. Please let me know if there's anything else. And as always, back up the video if you need to replay one of the questions we did. And good luck.